what we want to look at in this section, we're still talking about sets of data. We've talked about like finding the middle of the set of data, finding out how spread out the data is. The next component we need to be able to look at is really two things. We want to be able to compare different sets of data, and we want to be able to identify any outliers, any extreme points. Comparing sets of data can be a problem in some instances. You know, if you are in two different classes and I ask you which class you're doing better in, you're probably going to answer with whichever one you have a higher percent in at the time, right? But if I told you you had a 90% in your biology class and the average was a 92, and you had an 85% in your math class, but the average was 75. Does that change how we think about it? Yeah, you have a higher score in the science class, but you are doing worse than your classmates. Versus your math class, you have a lower score, but you're doing better than your classmates. So how do we compare which of those scores is actually a better score? So the way to do that, we really need to be able to put everything in terms of a common unit. And that unit is what's called a z-score. So a z-score is basically a measure of how many standard deviations you are from average. You can do it with a population or a sample. It's the same thing. It's your value minus the mean divided by the standard deviation. So a z-score is basically just how many standard deviations you are from average. The formulas, you know, the only difference is notation, the mu and sigma mean the mean and standard deviation of the entire population, x bar and s, standard deviation and mean of the sample, so either one. We don't have to write units on it, just to measure standard deviation, so no units on that. Let's look at an example. The mean height of males 20 years or older is 69.1 inches with a standard deviation of 2.8. So if you're writing this down, you don't have to write all of it. We have males, the mean is 69.1, standard deviation 2.8. With our females in the same age group, the mean is 63.7 inches with a standard deviation of 2.7. Which of these people is relatively taller? So I know Kevin's taller, but relatively means in comparison to their age group with similar people. And so the only way to actually compare those values is to get a z-score. So we have to think about our two different groups. Okay, we'll have to look at Kevin. So we'll look at our males and females separately. So when we're talking about him, what is the mean for that group? And the standard deviation is 2.8. So if I want to find his z-score, it's his value, so his height, which is 83, minus the mean for his group, divided by the standard deviation for his group. Typically with the z-score, we just do 2 decimal places. So we get a positive 4.86. Yeah. So the positive meaning he's above average, so a negative would mean you were below. Okay. So he is 4.96 standard deviations above average. So then we do the same thing for her. Her height is 76. What is the mean for her group? divided by the standard deviation for her group is 2.7. So we get a positive 4.56. So they're both above average. Who is more above average? Kevin is. On the interpreting for these, you really want to make sure you're paying attention because I may not always just be asking for the biggest one. You know, if I had 2 test scores and both Z's turned out to be negative, what does that tell us?
I think that's all I have ready for you.
They're both below average. So if I said who did better, you would want the one that was closer to 0, right? The bigger the negative, the worse they did there. So you kind of have to think about what the application is. If I were talking about like your times for running a race and you had negatives, what does that tell you? Were you fast or slow? What? If it's a measure of how long it took you to run a race, you would want to be below average, wouldn't you? That meant you ran it faster than everyone else. So you have to look at the context of the problem to know how to answer the question on those. All right. Any questions about z-score, how to calculate that? We will use these a lot. The second thing we want to talk about is percentiles. And a percentile is a value such that I'm going to say K% of the values are less than or equal to. So you might see this like if you're looking at standardized test data. They might tell you you scored in the 85th percentile. That means 85% of the scores were less than or equal to your score. Okay, so the key thing with percentile, it's less than or equal to. Tells us what percent is less than or equal to. So just a quick example, really just an interpretation. So the GRE is a test required for admission to many grad schools. University of Pittsburgh requires a GRE score of no less than 70th percentile for admission to their human genetics program. What does that mean? So what does it mean if they say you can be no less than the 70th percentile? So your score or, okay. So if you're in the 70th percentile, that means 70% of the scores have to be less than or equal to yours. So to get in, 70% of the scores another way to think about it, you know, if here's the 70th percentile. What happens, all of these scores get kicked out, so how many people do they end up taking? Yeah, the bottom 70 gets kicked out. Another way I think about it is the top 30%. Get it? Okay, they take the highest 30%. Percentiles are useful in talking about quartiles, which is something we will use a lot more than just a regular percentile. So a quartile really just divides our data into fourths, just like 4 quarters and $1. So they are specific percentiles. So the quartile 1 is when 25% of the data are less than that. So another word for quartile 1 would be the 25th percentile. Use P for percentile, a little subscript 25 to tell you that. Quartile 2, that's the same as the 50th percentile, or called the median of our data. We've already found that. Quartile 3 would be the 75th percentile. So that's the value. All right, so this is speed data for vehicles going through a construction zone. So we have 14 vehicles. I want to find the quartiles. Quartile 1, quartile 2, quartile 3. My recommendation to you, first of all, I think I was nice and I did put this data in numerical order already, but make sure it's in order from small to large. I would start by finding quartile 2 because we've done that before. It's the median. How do you find the median? We need the middle, which would be right here, because then there'd be 7 on each side. So the median, we would have to add those together, divide by 2, and we get 32.5. Okay, so what this means is 50% of the speeds were less than or equal to 32.5 miles per hour. Okay, so then quartile 1, it's really just the median of the lower set. So here's the bottom half. If I asked you to find the median of that half, what would it be? The middle number. So that 28 is my first quartile. What does that mean if I asked you to interpret it?
25% were less than or equal to.
Okay, and then quartile 3 is just the middle of the upper half. So if I look at my upper half of data, the middle of that would be 38. And the interpretation, I'm not going to write it this time, but what would the interpretation of that be? 75% of the speeds were less than or equal to 38. Or you could say 25% of the speeds were above, greater than 38, yes. This can also kind of give us an idea of if our data is skewed. If we looked, how far is it between quartile 1 and quartile 2? If you subtract those, 4.5. How far is it between quartile 2 and quartile 3? So are those numbers pretty close to each other? Yes, so that's a pretty good idea that our data is fairly symmetric. If one of those differences was really large, so maybe this one was 13 and a half, that would be a big indicator that, oh, I must have had some really high values there. So that would tell me that my data was probably skewed. So just another little check we can do to see if we have symmetric data. Any questions about that? The next calculation we can do is what's called the interquartile range, IQR, which just like everything else, this is on your formula sheet. We've talked about, we're in chapter 3 right now, we did C-scores today. The next bullet under that is the interquartile range, the last piece we're looking at today. And it's basically just the range of your middle 50%. It's quartile 3 minus quartile 1. So if we wanted to go back and find the interquartile range for our example, IQR is quartile 3 minus quartile 1. So that would be 38 minus 28, which is 10. What that tells us is basically the middle 50% of speeds were within 10 miles per hour of one another. Okay, there's 10 miles per hour difference in the beginning and end of that range. This is just another way of basically measuring spread. The higher the value, the more spread out they were. If it were a 75 mile per hour, that would be a huge gap there, and that would tell me this data is really spread out. I must have had some pretty low values and some pretty high values. So the smaller the IQR, the more symmetric our data is. So I want to go ahead, I think I'm going to do one last example, and then we'll probably stop here for today. I'm almost done with this section, but let's say, we have a 15th car that goes through our construction zone at a speed of 100 miles per hour. And I want to look at how it changes the mean, median, standard deviation, and interquartile range. Right, we have not calculated all these things to begin with. But what's the easiest way we can get all that stuff? Okay, so first let's go to our calculator and put in the original points. Do I need to put them back up here? Okay. I'll come back to the slide in just a second if you need to write something down. So go to your list. And we want to put in all of these speeds. I should have 14 of them. And then everybody go to your one variable statistics. I want to show you something. So we know our means, 32.14. Standard deviation, 6.175. If you go down, notice it has like in, min, and then what's the next thing on your list? Q1, it gives you your quartiles as well. Is that the same as we had for our first quartile? And then it doesn't label it as Q2, it calls it the median, but we know the median is the second quartile, and then it gives you Q3. So your calculator will do your quartiles for you as well. Interquartile range, we could use our calculator, Q3 minus Q1, which we already did this calculation. We got 10. So now, let's look at our new data. So we want to go back to our list, and you want to add one more point on the end of 100. So now if we look, our mean 36.67. Standard deviation, 18.504. Median is quartile 3, or sorry, same as quartile 2, which is 33. Interquartile range, quartile 3 minus quartile 1, and we get 11. Give me just a minute. Okay, so I want to notice something here. Let's compare the mean. Did this change a lot? From the old to the new? I mean, you went from an average speed of 32 up to an average speed of 36 because of one person. So that kind of, I mean, it's not a drastic, like, oh my goodness, but it's a little bit of a change. So that's a bigger change. What about the median? It went from 32.5 to 33. It went up half a mile per hour. Did that change much? Okay, standard deviation, was that a big change? Yes, it tripled because of one person. Okay, IQR, it went from 10 to 11. Was that a big change? No. So we have talked a lot about this, things that are resistant. We know, we've talked about the mean and the median before. The mean, if you have one extreme value, it changes a lot. Okay, so if your data is skewed, the mean is not going to be as accurate. The median is pretty resistant. A change doesn't really affect it much. We're seeing the same property with standard deviation and interquartile range. Standard deviation changes a lot because of one extreme value, but interquartile range does not. So the last thing I'm going to mention today is this just kind of a summary. We've talked about this a little bit, but if your data is symmetric, you want to use the mean and the standard deviation. Those are the best values. But if your data is skewed, then the mean and standard deviation are no longer accurate. So then you would want to use the median and interquartile range. I am almost done with this section. I really just have 2 slides left. So I will finish it tomorrow, but I do have a handout for you that I'm going to go ahead and give